All right, ready? All right, well, welcome to Shark Attack. We're going to talk a little bit about HTML5 and some of the wonderful goodness that the W3C has provided for us. My name is Tony Delagrange. I work for Secure Ideas. I've been in various security roles for quite a few years. Bit of a geek, worked at a large financial institution for a pretty long time. Co-author of SANS Sec 571's mobile device security class, and thank you. And project lead for MobaSec. That was our first DARPA project that we did that we released at the beginning of the year. It's focused on mobile device security. It's now an open source. I should say it's been an open source project, so it's freely available. As you'll find out, we're a pretty big fan of DARPA CFT program.
All right, and I'm Jason Wood. I started out as a systems administrator and kind of bounced around between the Unix and Windows world, and spent a lot of time in infrastructure, basically how everything worked, and then moved into security. Survived the .bomb stuff. I got to actually be at a company where we watched our CEO and CFOs get arrested and found guilty of all kinds of stuff. So that was...
Now, how fun is that? How many of you would love to see your CEO get arrested? No, don't raise your hands. Don't raise your hands. Don't raise your hands. Oh, come on.
It's fine now.
James, put your hand down. James, put your hand down.
So anyhow, I actually write a script, a couple of scripts, do username generation called Reconnoiter, which maybe some folks have heard about, and I have no idea why I'm in a shark suit.
Well, we tried to get him to wear it, but we just couldn't convince him to do it. So we're going to talk about HTML5, and of course when you talk HTML5, you got to think about client-side attacks, and well, then you have to ask the question, why? All right. I mean, everybody's focused typically on the server. You want to get shell. I got to get shell. The focus is on getting shell. But there's so much goodness there and on the client side. Now, okay, you might say, well, come on. I mean, we got phishing. We've got social networks. This is nothing new, right? Well, yeah, you're right. And we also know that users will click on just about anything, right? So why aren't client-side attacks typically part of pen tests? Well, that's typically the biggest reason why. The client's gonna say, why do this? I know they're gonna click on stuff. What's the big deal? But you have to consider what additional risks are being introduced into your environment because of these client-side attacks. And now with the W3C still trying to ratify the HTML5 specification, that specification is introducing all sorts of wonderful new types of features that could be used by attackers. So how much do you know the vulnerabilities that are now being introduced into your organization because of that? So we're going to talk about a common client language, the HTML5. I would imagine most of you already know this by now. I mean, if you don't, kind of where have you been, right? Yes, it's not been ratified, but pretty much all the browsers are using it, right? I mean, maybe except for the exception of Opera Mini or something like that, pretty much every browser is using most of the functionality of HTML5 that it provides. Some of them don't. They kind of degrade slightly as you start getting to some of the obscure ones, but a lot of support out there for it. So we had to think about this. It's like, well, why do we have this specification? I mean, really, what was the W3C thinking? I mean, did they forget? It's not just a markup language where you're displaying things onto the screen, right, or into the browser. This is an actual application language. I mean, you've got code that's actually running on the client side. Now, how many of you think that we should trust the client? Oh, wow, we've got 3. Love it. Where do you guys work at? We can't trust the client, right? You have to figure the client has been compromised when you're writing your code. So let's talk about some of these wonderful features that have been provided. We'll just kind of give you a couple of them for right now, like, getting the temperature of your hard drive. Now, how wonderful is that? I mean, obviously I want to know the temperature of my hard drive within my browser, right? Or voice recognition. Now, has anybody used the Google voice recognition? I mean, really? Do you really? Okay, I'm just curious, because honestly I knew it was there, but I didn't use it that much. It's kind of interesting, but still, what's the purpose? I mean, really, what's the need? So we looked at, well, what all the browsers that actually support HTML5. What are the top ones, right? Chrome, biggest supporter of it, and it has been for a while, and I think will continue for a while. They are a big adopter of HTML5. Surprisingly, in the tablets, RIM. Is there anybody still using BlackBerry? I'm just curious. Anybody? Oh, yeah, we got 1, 2, okay. Big supporter of HTML5, but not too many people actually using their playbooks.
And it's kind of washed out here on the screen, but Chrome again is right behind it, almost the same score. It got scored 371, I think it was, for the Chrome tablet browser. So it's right there in the middle of it.
Now, if you want to try this out yourself, it's html5test.com, so you want to see how much does your browser that you typically use support HTML5. But again, they've got a place where you can take a look and see all the different types of devices, the ones that support it the most. What I get a kick out of is gaming devices over here and televisions. I mean, what could be wrong with that, right? I mean, now my television is going to be supporting HTML5, and in this case, the biggest one is the Sharp Aquos. What could go wrong? Especially if you're able to stage client-side attacks. That's your TV that you might be able to attack if it's connected to a network or to the internet.
And everything has a network jack.
Yeah, exactly. Speaking of which, what are some of the attacks with HTML5? Again, with all these new features, we feel there's all sorts of potential for attacks using these features. I'm kind of wondering if the W3C actually has some black hats working for them in developing this specification.
Well, one of the things I thought was interesting as we were looking through some of this stuff was actually some of the debates going on where somebody comes in and says, hey, there's a real security issue with this. We need to disable this, we need to change this is a bad idea. And I'm listening to the same arguments that I got from the web developers I worked with is why is this a problem? I don't understand what you're talking about. So things are being put into the specification that security folks are waving their arms around, and other members of the W3C just they don't understand what's the problem with that.
So one of the things we've seen is that the HTML5 provides a lot more new events, and these events are across all the different tags that are available, not just a specific few. Also keep in mind that all these features are across all sorts of various types of browsers. So it's not like it's singling on a specific browser like just Chrome, all right? Because it's dynamic nature, it allows you to control pretty much anything that the browser does. I mean, if you got JavaScript running on this thing, which is part of the specification, and it's executing, everything's available to JavaScript, everything that's within the browser, you can control it if you're able to compromise it. Now, the other wonderful thing is that, well, these features can be disabled. Yeah, some of them. Most of them can't. Some of them require you to opt in, but they're not real consistent from one browser to the next is what we found. And a number of them, if you do opt in, basically it remembers that. And you're opted in, at least for that domain, from then on.
And if you want to disable that, you're going to go play hide and go seek in your browser for that setting. Try and figure out where did I put that. So if you decide to change it, good luck.
So last year, Security has participated in a survey. I think it was Secure State, right?
No.
No? Okay. We participated in this. Yeah, that's what I thought we did.
Different survey.
Sorry to put you on the spot there. Wake up. And basically, it was just a very casual survey. We went out there and said, hey, look, we'd love everybody to click on this link. Now, usually when Kevin Johnson or Tom Esten, not Liston, sends you a link, you really shouldn't click on it. But fortunately, we got people to click on this link, and we found out that almost 75% of those people were running on desktops with their browser that supported HTML5 and different features. More than 25% were running on mobile devices. But the two top features that were supported by all these different browsers that clicked on it was local storage and geolocation.
And geolocation on your desktop. So it's picking that up somehow. Not limited to just your mobile device.
What could possibly go wrong?
Yeah, what could go wrong? And the amazing thing is that we've seen different web applications that we've done in some of our testing where every request, there's a geolocation information lat long that's being passed. Why? Because you can. So what are some of the cool features? And when we say cool, we're thinking cool from an attacker perspective, right? Oh, sorry, I'm on your way. I got waved. Get the hell out of the way. Wait, you can't see that? These are some of the features that we thought that, well, you know, as we're looking at this, what could go wrong? What could an attacker use with some of these features? And these are just some of them that we picked out. You know, WebSockets could be used for doing some kind of network scanning. Consider the perspective of being able to get JavaScript to run on a browser, on an internal corporate network, and be able to scan that internal network. Local storage, you know, where can we hide some information? Where do the developers hide some information? Maybe they stuff some not cookies, but like credit card numbers and whatnot.
I've seen some ridiculous stuff tossed in like the view state of ASP.NET applications, just insane amounts of data because they had it there. They could put it there and it had more space than a cookie did. So I could totally see you guys looking at the local storage and saying, great, now I don't have to worry about this, we'll just save it to the browser.
Well, and here's an idea. If you're doing a network scan of an internal network and it's not able to connect out to your attack server, where's a good place to store it, right?
Until we have a connection.
Right. Web workers, those are nice little tools that allow you to run some JavaScript in the background. The user doesn't even know it's running, and we'll see that a little bit later. And app cache, great. This is fantastic for the same purpose. I can take this JavaScript and it can be loaded and cached on the browser. You don't have to have a connection back to the server. It will keep on running. And then geolocation, obviously we already talked a little bit about that. And event attributes, yeah, it's great. Event attributes, you know, you can use some of these attributes to do all sorts of wonderful things now, like control the volume, you know, pause, play. Well, that's nothing new. Yeah, but it's launching JavaScript. If you're able to get your own JavaScript code in there, when they go to do something like change the volume, you've got some access there. And then cross-origin requests.
Right, so now your XHR that was limited by same origin policy, if it's configured improperly, or a developer has modified the HTTP header improperly, that works across domain. So we lose that protection.
So if you hear this music, what do you think you should do? I mean, how many times have you seen a movie where you hear the music, or it's that creepy music, or hey, I got an idea, let's separate. Yeah, that's a great idea. It's time to run.
All right, so what we have done here is we've created a new project called Sh5ark. It's essentially the Securing HTML5 Assessment Resource Kit. Which is, yeah,
That's a mouthful, isn't it?
we all have to look it up, and so we just call it Sh5ark. Essentially what we've done, you notice everything we've described is stuff you could do previously with different methods. Network scanning the internal network as you compromise the client isn't new. However, this is a new way to do it. And so some of our defenses, monitoring, things like that, you know, may not be there for it, and it slides past into our network in ways that we didn't expect before. We've gathered up a lot of this information from existing research that other people have done and brought this really into one place to have it be used by anybody who would like to learn more about the HTML5 features and how they can be abused. In particular, what we did with it is you're not just looking at snippets of code, you know, saying, here's how you do this, here's the feature works. You can click and interact with it on this simplified page, but there's actual code sitting here. Here's an attack. It has the code for it right there. And so you can work with it and see it, you know, end to end. Here's the page, here's the attack, and here's what's happening. So that was kind of the idea behind Sh5ark. Gather all this up so that we can use it, and so we can get familiar with it and use it in our environments to either check for issues, penetration tests, or check our filters on our IPS or web app firewalls, things like that, make sure they're working properly.
Yeah, one of our biggest drivers is what kind of gave us the idea of this project was that we just really didn't see a nice repository that brought all this kind of research together. I mean, yeah, there's some really good tools out there. Beef, I mean, love Beef, right? And it uses some of these HTML5 capabilities to do some of the things that the wonderful goodness that it does. But we really didn't see anything where it's like, look, if I want to really look at HTML5, where's some sample code that I can use that shows me how those features work? Where's some of that sample code that I can actually do some of these attacks? And well, where are some of the filters that I can help prevent some of these attacks or some of these features in my environment? So that was the whole idea, is to be able to pull all this together in one repository. And keep in mind, this is just the beginning. We were just starting off. Our intent is that now this is an open source project. We want the research to begin, even more research, and to add on to this.
And this came out of a DARPA Cyber Fast Track funded project. So that was how we were able to spend the time on this to go ahead and do this project. And it's been really pretty cool to get a chance to work with this. We've got it on SourceForge, so just sourceforge.net/projects sh5ark. Okay, is where you can download that at. Inside of the project, what you're going to get here is some configuration files and some HTML, JavaScript, things like that. And it's essentially a website that you dump into your web root, and you can start to take a look at the features. It's divided up by features, the attacks, and then what we're calling repellent, essentially the filters to block that. We used mod security rules written for that. So, you dump it on your server, and you're able to start working with it and checking it out. Inside there, we also have some Excel spreadsheets, giving some of what we found out as far as here are the different features and which browsers are they supported on, and that got spread out across desktop, mobile, tablet type devices, phones. I mean, it really had it was a long list, same with the attacks. Where were we able to get these attacks working?
Now, our intern was rather busy testing this out with about every device we could get our hands on.
No one's groaning.
He had to do an interpretive dance while he was doing it with the mobile devices, though, so it was kind of interesting.
Now, there are some things here with Sh5ark that we wanted people to be aware of. This was built and done on Ubuntu 10.04 LTS. So if you're looking at the configuration files that we include in the project, that's what they're geared towards. I tend to like FreeBSD, so I have to change things to work in my environment. All you really need, Apache, mod security, PHP, and you're pretty much ready to go. There are some issues, though, that when we were delivering this to DARPA, we gave it to them in a VM all ready to go. And so there's some static IP addresses coded into it at this point, so that's something we're working on. It's not the most...
Definitely not the most elegant,
yeah.
But it was something we had to do as far as getting some of the features and the attacks to work, because they're doing like maybe a cross-domain type of connection. We want to be able to demonstrate that, right? So we used some static IP addresses in that setup, and the code is kind of coded that way. Not great, but it does work. It does give you an idea of it, and within the repository there are pages that tell you how to set that up. So it's not like you got to sit there, scratch your head, and go, all right, what they set this to? That information's out there.
Right. In fact, this is going to be the default page. You go to your web root and where you have Sh5ark set up, and this is going to be the page you're looking at. And you see, we start talking about, okay, well, here are the IP addresses. It uses the Ubuntu syntax here for defining your interfaces and the aliases. And then down here at the bottom, we've got the links to the features, the attacks, and then the repellent. So that's how we kind of split this up and are able to move around and work within it.
I think I know this guy someplace. I think I've seen him riding around someplace out here in Louisville. So let's talk a little bit about the HTML5 features that we're looking at, some of those cool features. The event attributes. We've got some code samples up here. Again, this is all in the repository for you to take a look at, but just to kind of give you a glimpse of what's in Sh5ark. You'll see with the video tag, we've got some event attributes, on play, on pause, what have you. This is where you can insert some of your code, or in this case, being it's a feature that's being used, the developer can leverage this code so that when someone clicks on pause, something can pop up, or basically execute any kind of JavaScript code that they want, okay? Web workers, same way, very easy to kick off. If you got a JavaScript file, you just start off a new web worker, tell it where it's at, what the file is in the JavaScript file, and off it goes and off it runs. And it's something that can run in that background while your user is still able to do something on the front end. So this is something that's executing basically in the background for you.
And it doesn't interfere with their experience using the browser. You know, it's not like the page isn't responding anymore because we're waiting for this JavaScript to complete. It's been backgrounded, the page just moves on while the web worker does whatever it does. Yep.
Just curious, do the background threads have access to the same things that the main thread has access to? For example, access to the DOM, scraping anything that I might want to send across, but not hang up the browser?
I'm not sure. I would think it's going to have pretty much anything within that domain that the JavaScript has access to.
No.
No?
No.
How does that work?
Depends,
What's that?
depends on the browser.
Oh, so the question, sorry, for you guys in the back. The question was, you fire up a web worker, what does it have access to? Does it have access to all the normal stuff that the main thread would have access to? The DOM, whatever resources that you would be running in there. And I guess what I'm hearing depends on the browser.
In most cases, it does not have access to the DOM due to basic conditions. The W3C is working on fixing that problem for them.
Okay, so Kevin's response here is that currently they don't interact with the DOM because of some race conditions. And in his opinion, they're working on fixing that so that it will work so that pen testers can have a good time.
Then, of course, Web App Cache that we talked about earlier allows you to take some of this code and store it locally in the browser. So if you don't have a connection back to that server, that application can still load. That JavaScript and HTML can still load locally from the browser and continue to execute.
And a great example of that type of app is the Kindle application or HTML5 app that that Amazon wrote for the iPhone and the iPad. They didn't want to. They wanted people to be able to shop within the Kindle application, but they didn't want to send Apple 30% of the sale like Apple requires. So they created this HTML5 app. You essentially drag it out onto your tablet, you open it up, and you can sync books to your local storage. I hop on an airplane, throw on airplane mode, open up the application, and it runs just like it was if I was connected online. I can't sync anything more, but it works just fine. Yeah.
Does the specification say whether or not that thread gets destroyed when you move to a new page?
As far as the web workers, so we were messing with that. I'm not sure what the specification says, but what we saw is when we moved to a different page, it stopped. Oh, sorry. The question was with the web workers, when we move away from the page or whatever, does it destroy that thread or that process? The answer is that what we observed, not what the specification says, I'm not sure there, but what we observed is when we leave that page, the web worker dies and quits running. So it's not going to be something that you could fire up once, and as they navigate through the page, or through the site rather, it's going to keep running. Now what I thought about at this point was, okay, do a pop under and then kick it off there. How often have you been, doing something online, you go to close your browser out eventually, and you find this pop under hanging around for something or other. You just didn't even notice it. It hit your system. So, that could be there for a long time before you see it.
Or if you have a page that's very interactive, it's going to keep the user there on that page. It's going to be running in the background while the user's playing, some game or whatever, something like that. It's in the foreground that they keep there, or hey, maybe even better, they just leave it open and go to some other page on another tab.
I don't do that. Nobody leaves tons of tabs open.
I didn't say you did. But wait, there's more, of course, cross-origin request sharing. And this is kind of nice because you can request resources from another domain. This can be controlled. The problem is that I'm thinking a lot of developers are not going to notice this, right? They're trying to develop an application. They're going to go through as quickly as possible and say, look, I just want to get this running. And they may not even know some of the domains that they're running within. Set it to asterisk, it makes it universally available, any of those domains.
Yeah, it gets synced up to our code repository. you do all the proper stuff, you pull your deployment out of source and you move it up to production, everything's QA testing beautifully. What you didn't realize, and you have your server set up not to, because in Apache you can go ahead and set the access control here for cross-origin request sharing and not have it specified, so it won't be there. But the developer can go ahead in their code and just say, grant star to this. It works now beautifully in their environment, in their dev environment, and as they move it through all of the different, dev, QA, and stage, it continues to work, and all of a sudden it's on your site.
So we've already talked a little bit about local web storage with local storage and session storage. And the difference here is, with session storage, it's going to be gone after the session is ended. But local storage, it can stay there persistently, even if you've moved away from the page, close the browser, what have you. Also, as we stated, local storage, this is going to give you a lot more storage space than cookies. So if you have a need to store a large amount of information, local storage can be your friend.
There are limits on it.
There is?
But it's like 32 megs. So it's pretty prompt.
Can't store much in 32 megs, right? And then geolocation, just a little example there of how you can get current position. Again, it's amazing. You will see a lot of that with mobile apps that we've kind of seen in different talks. But also even with it just on desktop with web browsers, you'll see a lot of requests that are trying to capture that location. So in Sh5ark, this is basically what you're going to see from a typical HTML5 page. Basically break it up into 4 different areas. First, we're going to start with like a description, with a title, what that feature is. Sometimes a little bit more verbose with what the description is. A little example of what the code looks like. The browsers that support this. Now, keep in mind, this is not an exhaustive list. This is a lot from the research that we did, but obviously this is going to change over time, especially if the specification continues to change as it is. And then a nice little area down at the bottom where we actually have the code on the page or some JavaScript that's on there that you can test it out and see how it works. So now let's talk a little bit about Sh5ark tags.
Right. So now we're going to take a look at, we have those pages set up where we can look at the features, they're functional and working, simplified, so we're not digging through a bunch of extraneous stuff. Now we're going to do the same thing for our tags. The first one we have here is network reconnaissance. You can do things like ping tests. And when I say ping, we're doing up here we're doing a WebSocket and we're specifying a port, checking to see if a host is alive. So you pick some common ports that would be on a network and just see if they respond back. We're not talking about ICMP necessarily, but nothing that hasn't been done before, but totally new way of doing it, and something that may slip past our defenses. We also have the option to use cross-origin request sharing. If that's set to star, we can go ahead and set our page, or our attack rather, to use that instead. So we can't get away with WebSockets for whatever reason, but now I can with XHR, and everything pretty much supports some kind of AJAX type of request. Maybe the syntax is a little bit different for IE, but we've got that functionality there. So now we're going to go ahead and tempt the demo gods a little bit and see if we can get some demos to work. Now these are pretty simplified and straightforward. We've slowed some things down so that it's actually visible to what's happening. So first off, we're going to go ahead and do a quick network scan here against this VM that we're running. And in this case, we're going to enter in the range 10.10.1.170 to 10.10.1.180 and tell it to look for port 80, just the service that it's checking for. And we used an existing bit of code called JS-Recon for this, just to demo this. And so we go ahead and launch it. You can see here down on the bottom, actually probably can't see from the back, what you have here is a scan log telling you, okay, 10.10.1.170 is down, 172 is down. 174 is up. And then at the top, when the scan finishes, it updates up here live hosts and tells you what hosts are available. You're also able to go ahead and do things like port scans. Now this is very simplified port scans. We're going out and we're connecting to different ports and seeing if we get a full connection. We're not going to go and be able to run nmap syn scans or whatever through this. But still, we've shoveled this down through the browser using a different method than would normally be available to us.
I like that part. It says it currently only works on Windows.
Yeah, it currently only works on Windows, but it works pretty well here on this Linux box.
And keep in mind that, basically what we used, this is not code that we developed. This is stuff that we pulled that's already existing out on the internet. That was part of our research, was to find what's out there, what's existing, let's pull it together in this repository. And so you find some things that's like, hey, this is only going to work in Windows, but we want to try it anyway. And obviously it works pretty good.
So that's taking a look at doing a network scan. Very basic. I mean, there wasn't anything super exciting about that, but I mean, that was all just done through the browser with the new features of HTML5. Next, what we're calling here is kind of a denial of service attack, or distributed denial of service attack. You have something where you're able to inject something into a web page that's spread out to a large user base and start using web workers. And yeah, I keep saying WebSockets and web workers. I want to double check and make sure I had that right. But you fire off a new web worker on all of these systems. Like I said, the page continues to work. I'm not sitting here waiting for the JavaScript to finish rendering or running before the page renders, and I can interact with the rest of it. It goes to the background and does what it's going to do. So pretty simple code here to do it. It's just a few lines that we have here up in this particular slide, but it's very straightforward syntax. And we'll go ahead and take a look at another demo. So in this case, we're going to go ahead and start out underneath test it. And what we're doing is we're making a bunch of web requests with this background worker process. And if you look down here where Tony's highlighting, you can see, or those close enough, can see the time changing here. The current server time is updating constantly, so the page is refreshing. You can go ahead and select get the current date and time. That runs just fine. The drag and drop functionality of HTML5 is responsive and the whole bit. In the meantime, this thing's churning away here. By itself, yeah, that's not a denial of service attack. Spread this out large enough user base of all of these requests coming in, and it can become so. Particularly if you start sending these requests to, let's say, a very database-intensive page on your target website, and their database servers fall over, which I've seen happen. So those are that's how we could go ahead and do that type of denial of service attack.
Dude, that looks like James Jardine. Is it? Did we hire Rick Astley?
I think so.
Oh, wow, cool. Hey, James, can you stand up and do us a song?
No. Watch out, he's pulling out the bottle.
And it's full, so watch out.
Yeah, but what is it full of?
Don't want to know.
Don't want to know.
So in this case, we're talking about messing around with the browser history a little bit, and or even what's displayed up inside the URL, the address bar. So the first item here, essentially we're going back through somebody's history and rickrolling them over and over again 20 times. Just overwrites their history. It could be useful if I want to keep somebody on a particular set of pages. Maybe I want to blame them for something, make it look like they did something they didn't. Or in the case of the bottom, what we have here is this history.replace state, and we're putting in www.bankofireland.com/login.php. And
Why Bank of Ireland? Do we have something against them? We don't like Ireland?
not that I
Are
know
there any
of.
Irish here in this? Okay, good. We don't have to apologize then. Go ahead.
Anyhow, the idea here is that we're going out and we're trying to phish somebody. Yes, it has our domain name up here in the front, but then they see www.mybank.com. Well, it looks all right, so we'll go ahead and log in. So just a way of obscuring what we're doing inside of the excuse me, way of manipulating what the user sees and doing so again through another set of features that are new to us and inside of our environment. So Tony is going to go ahead here and select replace history, and it can't hardly be seen, but we've already updated the address bar up here to 127.001.www.bankofireland.com. So just a kind of a quick way of trying to phish somebody. The other is to go ahead and select alter history, and very quickly you go up here, and now the last 20 pages that we've visited is obviously this Rickroll page because we really like that song or something.
I hear James does. All right, so let's talk about some of the defenses that are provided within Sh5ark. Basically what we did was we decided to build some mod security rules. One, because, well, it's free, it's open source, so anybody can get access to it. It's got great integration, obviously, with Apache. And because there's a lot of other products and tools out there that do filtering that can either import mod security filtering rules, or it's pretty easy just to create them based off that. So that's probably a good place to start. One thing I have to mention is, a little embarrassed to say, is as we were going through this research, I had to remind myself, or I should say my boss had to remind me, that when you're doing this filtering, it's not about the responses coming from the server, coming down. It's about the requests going from the client up to the server. That's what we're trying to filter. Okay, why is this important? Well, you might think, well, wait a minute, I don't want to stop the use of web workers. We really want to use that functionality. That's fine. If that's coming down from the server to the client, great, no problem. You're not going to block that. What we're trying to prevent is someone from injecting some code that's going to leverage that as part of an attack that's going up, like as a cross-site scripting, maybe it's persistent or what have you. Okay, so keep that in mind when you're thinking about this. Don't go down the path that I did more than once. Remember that this is all about the requests coming from the client.
And the other reason why we did this is, we've spent a bunch of time here looking at the features and the attacks. We've been essentially putting our finger in the eye of the specification a whole bunch and pointing out problems and trying to break this down into a way that's pretty easy to understand and look at working examples. We wanted to provide something so that those of us who maintain environments and trying to protect them have a starting place to use that to try and keep from getting hosed.
So the example we have here is with the WebSockets, and you can see that we're generating, where's my finger, sec rule that's going to be focused on all the different requests, the URI, the body, the header names, the headers, and then over here you can see that basically we're trying to block any kind of request for a new WebSocket, okay? So anytime it's going to see that, if that's part of a normal request, we'll say normal, and I can't see why it would be, but if you have a normal request coming from your client to your server that says new WebSocket, then this is going to get blocked. Now, you don't have to block it. You obviously have an option over here where you can say, either deny, or you can just do notification, put it in the log. But this is a good start for it, and this is where you can build most of your rules from.
Yeah, stand it up in your environment, see what's happening. If nothing else from the monitoring side. I can't block it, I'm not allowed to because my boss is freaked out that I'm going to kill the site. So toss it up and log, see what's happening, get that information.
So within Sh5ark, what we did was we provided a way to test this. So you can leverage these rules, see how these features can be blocked with mod security. So what we did was we've got a page out there that if you submit that request, it's going to produce this one at the top. Basically, it's just going to pass, display what was passed to it. It's a PHP, simple PHP page. What we recommend is that you first make sure that mod security is disabled, run the feature, see what happens, make sure that it works, and then turn around and enable mod security, run it again, and depending on your environment, if you're using Apache, you should get a typical 403 with forbidden page display.
And this example here, and what you'll see inside of the documentation, again, is based on Ubuntu. A little bit different for your environment if you're running a different OS that's not Debian based. So.
And the mod security rules are in mod security CRS sh5ark.conf. That is in the Sh5ark repository under repellent. You're going to want to put that where your rules are typically placed. What we've got listed here is where we have it within Sh5ark under Apache. And then don't forget to restart Apache every time you enable or disable mod security. This is the test page that we made available, and pretty straightforward. You have a feature you want to try, like local storage here, submit a query, you should get that response that we showed below. Basically all the features that we highlight within Sh5ark are on this page, so you can kick them off, try them. They also each show what the filter is that's associated with that feature that we're trying to block. And then down at the bottom, if you want to try some of your own, we have this manual entry, and that's probably hard to see in the back, but that's where you can put in anything you want. You hit submit, it's going to send that. You can see how the filtering rules apply to that.
Or fire that off inside of your environment and use this as a way of testing out your monitoring stuff. I'm firing a bunch of requests here. I mean, you could do that with a lot of different tools, but I want to just look at HTML5 specifically and a couple of little things here that I'm dealing with. So I'll stand up my server and see if my IDS is picking this up the way I think it ought to.
Is that a GET request or a POST request it's sending?
What's that? I'm sorry?
From the manual, are you sending it as a GET or a POST?
It's a post.
So the question was, is this form sending a GET or a POST request when we're doing this? And POST.
Again, this is just the beginning. I mean, the whole idea was to get this started, get this research going. I mean, we know that there's a number of folks out there that are starting to do development in the HTML5 space. It doesn't get as much attention as we think it should. So the idea here was to get, start this off, get this going, put something that's out there. It's a collection of all the work that's already been done. Huge thank you to the people that have been doing that. We're hoping what this is going to do is spark a lot of interest to continue that, start building upon this and developing new HTML5 based attacks, as well as in that process, develop some filtering rules to help prevent those attacks or at least log and notify when that does occur. So basically it's a call out. This is an open source project now. So we really want people to get involved with that. If you've got some ideas, maybe you've been working on some research already, get involved with it. This is a place where we can help demonstrate what those vulnerabilities are, how those things can be compromised, and then how we can defend against it. Also thanks out to Chevy Chase for the original Landshark. Does anybody not know the original Landshark? Wow, thank God, I'm not showing my age too much. And then we also have the SourceForge link for you if you want to go out and pull down that project. And that's it. Any questions? Okay.
The local storage, is there any kind of a way to set expiration on that? Does it just kind of sit there until you can clear your cache out? I guess I'm saying if the developers store it on the drive, how persistent is it?
Yeah, the question is there any kind of expiration on the information stored on the local storage? I don't believe there's any automatic expiration that I've ever seen. So it's going to be stored there until it's manually cleared out.
My example about the Kindle application that I had running on my iPad, that thing stayed there for months and months and months. Every time I went back to it, my books were there, whether I was connected to a network or not.
Awesome. Might be a nice juicy treasure trove.
Oh, yes.
Absolutely.
I mean, I was just sitting there looking at this thinking, I cannot imagine what will get stuffed in here. Because I'm sure you can imagine.
I'm sure there's a lot of you.
Actually, I'm imagining what it is, and I'm not enjoying what I'm picturing.
Well, to make your life nice and easy, but make ours not so much.
Very much.
Another question, yeah.
How prevalent are you seeing HTML5 out in the real world?
I've observed it on a couple of tests so far already. So it's actually fairly easy to spot. Up there in your specification of which standard, or I'm using HTML whatever or HTML 4.01, it just says HTML. You're using HTML5.
Very often in mobile apps.
And yeah, very often in the mobile apps. But even desktop, aimed at the desktop, the whole bit, I'm seeing it on clients' apps.
And the beautiful thing here is that your application doesn't have to support it to be able to leverage HTML5 features to exploit, right? Because you're able to use some of these new features because the browser supports it. The application itself doesn't have to support it. Another question back there?
With respect to the WebSockets, I didn't get a good look at the security rule that you had up on the slide. Was it designed to allow sockets that the web page has permitted and deny things that you weren't expecting, or was it just a blanket deny all WebSockets?
So in this case, so the question was, is with our example here for the WebSockets filter, how, I guess, fine-grained were we on the control of what we were blocking and the whole bit? This is a very basic rule. If it sees anything starting a WebSocket, again, in the request going to the server, or trying to inject something that would start it, it is going to block it. So yeah, this is a pretty blanket kind of rule. It's not something I would necessarily toss into my environment as is, as a deny, but almost certainly a log. And so I can go back and see what's going on here. If I'm concerned about this, go down that route, and then I can fine tune this.
Yeah, and keep in mind too that with this rule, this is where it's a request, right? Not a response. So keep in mind that if that code, that JavaScript code is being served from the server down to the client, and it's going to execute on the client, this is not going to stop that. Okay? This is if you're submitting like a post up to the server that has that code in it, like someone's trying to inject that as part of an attack, that's where it's going to block it. But yes, it's going to block, this particular rule is going to block any kind of use of web worker that uses that command. Sorry?
The other rules for response?
No, mod rewrite, or mod security is looking at the requests, not the data coming back.
Can you go to the other slide?
Which one?
The one we had the other rules.
Oh. There.
So for the local storage, I mean, or web workers.
Another question? Sure.
As a web developer, is there anything I can do to mitigate some of these risks? I know that on one of your slides you indicated a means of filtering domains that get accessed, and I mean, granted, if generally someone else is going to be injecting something into my page, and yeah, the people in the background are probably going to complain they can't hear me.
We'll repeat it. So the question is essentially, as a developer, what can I do to try and mitigate some of these issues? And I think you were referring back to the cross-origin request sharing example, where we have domains that are specified here that are allowed to do those type of cross-domain requests. And really what you want to do is you're providing a whitelist. These domains can do this. So I want qa.mydomain.com and stage.mydomain.com and prod or www.mydomain.com to be able to do this and nothing else. Or, okay, and this other site out here that we've vetted this third party and the whole bit and or whatever, and we'll use that and allow nothing else. The concern is, and this is, I guess, from the operations guy, I mean, let's face it, I've seen what the developers I've worked with have done. They're working late nights, they're trying to get this thing done, they're pissed off because their code isn't working right. So they're trying to make this cross-domain request, and they just put star in there because they want to go home. And I can understand that. We'll come back later and clean it up. How many people have heard that story? We'll come back later and fix it. Yeah. It doesn't happen. We don't get a chance to do it because we're not allowed to, or we forget. It's just part of the deal. And so to answer your question, it'd be just work with your ops guys. What domains are what are my domain names I need to specify here?
But for the other stuff, it's basically someone else is going to be using the feature for me, most likely.
Yeah.
Prevent access.
Yeah. Yeah. I mean,
Another question?
Yeah, I just checked the SourceForge site, it's empty. Do we expect to see data there?
Drop the word trunk.
Oh, yeah, drop the word trunk at the end. You trying to do a checkout?
No, it says no files on SourceForge.
okay, so if you go to the Subversion checkout, you'll be able to pull them down. If you go to the archive that you would normally get, or distribution file, there's not anything there yet. But the code is in the Subversion repository, and so you can just pull it down.
I didn't check there, I just looked in the files.
I did the same exact thing when I saw it was committed. I was like, cool, let me, no.
Am I gonna have to give you crap?
Don't you already?
Yeah. Any other questions? All right, thank you very much.
Appreciate it. Anybody want a couple of bottles? I only have 3.
We've got the gentleman with the hat. You tap him on the shoulder?
With the beard?
Want a bottle? Oh, he already gave you one? Oh, okay.